Hello and welcome to this video. In this video, we will further read the documentation and I will cover set, frozen set and dictionaries. It has been quite boring for you, I guess, because we have been just reading through the standard library. But stay tuned and we are not, let me show you table of contents. So, not this. We are doing the standard library reference. So we are here. I will cover these two here. And then we have some context manager types and generic alias unions and other things. There will be strings, I guess, a bit later. We have exceptions. And in text processing services, we have regular expressions. So once we hit regular expressions, I will take a detour and discuss this in detail. It will cover lots of videos to fully explore regular expressions. And it doesn't matter whether you are a Python programmer or a Perl programmer or Ruby or something else. The ideas of this regular expression can be used in many languages. So this is going to be a very interesting topic. So for now, we stick to set and frozen set. So a set is an unordered collection of distinct hashable objects. And remember that all the hashable objects are immutable. So for example, strings can be part of set, but lists cannot. So mutable things cannot be part of hashable objects. We have seen the common uses when we started Python. So earlier we have seen membership testing, and obviously it can be used to remove duplicates from a sequence because sets cannot contain duplicates. And the typical mathematical operations like intersection, union, difference, etc. can be computed using sets. So it supports membership using an operator. It gives you length and it allows you to iterate on the set. But it is an unordered collection, so indexing is not allowed. You cannot do indexing, and that is why you cannot do slicing or other sequence like behavior. There are two built-in set types, set and frozen set. Set is mutable. You can invoke, add, or remove on it because it is mutable. Therefore, it has no hash value because it is mutable. On the other hand, frozen set is immutable and hashable and therefore can be used as a dictionary key. Now, in general, frozen set is not very useful, but certain problems in very niche areas, it can be very useful when it can be used as a key to a dictionary. So sometime later, I will present the uses of frozen set, but not now. So after this, the non-empty sets or frozen sets, sorry, non-empty sets, not frozen sets can be created by placing a comma separated list of elements within braces. The example is given here. Additionally, you can use the set constructor. Set constructor takes an iterable as an argument. Same for frozen set. So both take an iterable and they construct a set out of that. So there are three ways to construct a set. You can have braces, you can use a set comprehension, or you can use a constructor. Now it provides the following operations. So you can invoke length, len for length, membership, x in S, x not in S. These we have earlier seen. The other feature is disjoint. You can say there are two sets, A and B. Then you can say A dot is disjoint B, and it will return true if they have no elements in common. Otherwise, it will return false. So each subset is similar function. So next is set less than equal to others. So it tests whether every element in the set is in the other. Set less than other tests whether a set is a proper subset of other. That is set less than equal to other and set not equal to other. Similarly, we have superset is superset, set greater than equal to other. So this will test whether every element of other is in set and set greater than other. And similarly, you can, this is a shorthand for this. You can create, you can invoke union and you can pass a list of sets, and or you can use the pipe operator, both will work. So it will return a new set with elements from the set and all others. Similarly, you can invoke intersection or ampersand operator you can use, which will give you intersection. So it will return the set of all common elements. Difference you can invoke on a set and supply others as an argument, and that will be equivalent to using the minus operator, which will return a new set with elements in the set that are not in others. Symmetric difference is like XOR operator. So it returns a set with elements in either the set or other, but not both. And copy will create a shallow copy of the set. Note that the non-operator versions of union, intersection, difference, symmetric difference, is, subset, is, superset methods will accept any iterable as an argument. In contrast, their operator-based counterparts require their arguments to be set. So, for example, union, intersection, etc. can accept a list also. Okay, but the plus, minus, or symbols, if you use, then the arguments have to be sets. Okay. So using operators is far more readable, because if you invoke like this, where it is a string, then it is not readable. I think I'm wrong. This is more readable. This is not readable. So if you do intersection, it is very clear that you are using an intersection. But if you do this, then it is not very readable. So both set and frozen set support set-to-set comparisons. Two sets are equal if and only if every element of each set is containing the other. A set is less than other set if and only if the first set is proper subset of the second set, but is not equal. A set is greater than other set if and only if the first set is a proper subset of the second set. It is a superset, but is not equal. Instances of set are compared to the instances of frozen set based on their methods. For example, set ABC is equal to frozen set ABC returns true. So does set ABC in set frozen set ABC. The subset and equality comparisons do not generalize to a total ordering function. For example, any two non-empty disjoint sets are not equal and are not subsets of each other. So all of the following return false: A less than B, A is equal to B, or A greater than B. Since sets only define a partial ordering, the output of list.sort method is undefined for list of sets. So if you have a list, if you think that there is a list of sets and you want to sort it, that is not possible. So now we see binary operations that make set instances with frozen set return the type of the first operand. For example, frozen set AB, if you do an OR, that is the union, then it will return an instance of frozen set. And if set comes first, then it will return an instance of a set. Similarly, we have following operations which are available for set but do not apply to immutable instances of frozen set because it will update the set. So the member function is update and the operator notation is pipe is equal to. So it updates adding elements from all others. Intersection update is it updates but keeps only elements found in it and all others. Difference update updates the set removing elements found in others. Symmetric difference update will update the set keeping only elements found in either set but not in both. Add will add an element, remove will remove an element, discard will remove the element from the set if it is present. Note that remove can raise a key error. So it is better to use discard because it will not throw an exception. Pop will remove and return an arbitrary element from the set and it will raise key error if the set is empty. Clear will remove all elements from the set. Note that these operator-based methods, which we have studied, update, intersection update, difference update, and symmetric difference update, methods will accept any table as an argument. The elem argument to contains remove, discard methods may be a set. To support searching for an equivalent Freudian set, a temporary one is created from element. So with this, we finish our set and Freudian set, and now we move to dictionary. So dictionary I have covered in great detail earlier, but for the sake of completeness, let's go through its documentation. So the mappings are mutable objects. There is currently only one standard mapping type, that is dictionary. A dictionary's keys are almost arbitrary values, and keys have to be immutable because they have to be hashable. So you cannot use something like list or dictionary as a key in a dictionary. So there are several ways to create it. As you can see from constructor, one is use the parenthesis and give key value pairs using list comprehension, dict comprehension, and using the type constructor where you can supply list of tuples, two element tuples. So a list of two element tuples will create the dictionary. If no positional argument is given to the constructor, then an empty dictionary will be created. If a positional argument is given and it is a mapping object, a dictionary is created with the same key value pairs as the mapping object. Otherwise, the positional argument must be an iterable object. Each item in the iterable must itself be an iterable with exactly two objects. The first object of each item becomes a key in the new dictionary and the second object the corresponding value. If a key occurs more than once, the last value of the key becomes the corresponding value in the new dictionary. If keyword arguments are given, the keyword arguments and their values are added to the dictionary created from the positional argument. If a key being added is already present, the value from the keyword argument replaces the value from the positional argument. So we can see this is using constructor. Then we have 1, 2, 3 here. Then we have a dictionary using zip. Then we have another dictionary using an iterable and a dictionary from a dictionary. And in the last one, we have a dictionary where we have dictionary and keyword argument. So in all the cases, the dictionaries created will be equal. So now we look at the methods. If you invoke list method on D, it will return a list of all the keys. Len will return the number of items in the key. The parenthesis operator which takes an argument key and return the item with key. Now it will raise an exception key error if key is not in the map. If a subclass of dict defines a method missing and key is not present, then dekey operation calls that method with the key as argument. The D key operation then returns or erases whichever is returned or erased by the missing key call. No other operations or methods invoke missing. If missing is not defined, key error is raised. Missing must be a method, it cannot be an instance variable. Excuse me. So for example, here missing is implemented and it returns 0. So suppose we create an object of this, there are no argument. So if you try to find the value of the key read, it will return 0. And otherwise we can add 1 to it. So initially it will return 0 and 1 will be added, so that will become 1. So C read is now 1. Now similarly you can assign a value by using the key. Del D key will remove that item and it will also raise a key error. Key in D is a test of membership. Similarly, key not in D is a test of non-membership. Iter D will return an iterator over the keys of the dictionary. It's a shortcut for iter supplied with the D dot keys. Clear will remove all items from the dictionary. Copy will create a shallow copy. And the class method is from keys. Create a new dictionary with keys from the table and values set to the value. From keys is a class method that returns a new dictionary. Value defaults to none. All of the values refer to just a single instance, so it generally doesn't make sense for values to be a mutable object, such as an empty list. To get distinct values, use a dict comprehension instead. Like getting the value of a key, you can invoke get, and it takes key as an argument. So it returns the value key if key is in dictionary, else default. So you can supply a default value with the get method, and by default it is none. So since we have a default none always, it will not raise a key error exception. Then we have items. It returns a new view of the dictionary items key value pairs. So view means if the dictionary is updated, the view is also updated. Keys method will return a new view of dictionary keys. Pop will take an argument key and optional argument default. So it will remove that key and value and returns the value. If the key is not in dictionary, it will return default. If default is not given and key is not in the dictionary, key error will be raised. Pop item. It removes and return a value key value pair from the dictionary. Pairs are returned in last in first out order. Pop item is useful to destructively iterate over dictionary as often used in set algorithms. If the dictionary is empty, calling pop item raises a key error. Reverse D will return a reverse iterator over the keys of the dictionary. This is a shortcut for reverse D dot keys. Set default. If the key is in dictionary, then it returns its value. If not, it inserts the key with the value default and return default. Default defaults to none. Update. Update the dictionary with the key value pair from other, overwriting existing keys and returns none. Update accepts either another dictionary object or an iterable of key value pairs as tuples or other iterables of length 2. If keyword arguments are specified, the dictionary is then updated whose key value pairs with those key value pairs d dot update red is equal to 1, blue is equal to 1 will overwrite the keys red and blue with values 1 and 2. Values will return a new view of dictionary's values. So that means if the dictionary is updated, then the view will be also updated. D type other, so it creates a new dictionary with the merged keys and values of D and other, which must both be dictionaries. The values of other takes priority when D and other share keys. D pipe is equal to update the dictionary D with keys and values from other, which may be either a mapping or a table of key value pairs. The values of other take priority when and other share keys. Dictionary compare equal if and only if they have the same key value pairs regardless of alternate. Other comparisons less than equal to greater than raised type error. Dictionaries preserve insertion order. Note that updating a key does not affect the order. Keys added after deletion are inserted at the end. So this is an example which shows this statement. Dictionary and dictionary views are reversible. So if we have a reverse here, then we will see 4, 3, 2, 1, and reversed values will be 4, 3, 2, 1, and reversed items would be 4, 3, 2, 1. Similarly, we have dictionary view objects. So keys, values, and items, as we have seen, will return view objects. That means when the dictionary entries change, the views also change. We can invoke len, iter on dict views, membership, reversed, and the mapping of this. It returns a type.mapping proxy type that wraps the original dictionary to which the view refers. We will see this later. So I think we have covered the set and dictionaries here. Now, in the next video, I will go through context manager types, okay, and possibly have some examples for you for context manager types, because this is something which we have not studied earlier. So it would be good if you can spend some time. I hope that you have found this video useful. And let me know what you think of the video in the comments. And thanks a lot for watching. Happy to learn.